The idea of parallel universes has captivated the human imagination for centuries. From ancient myths to modern science fiction, the concept of alternate realities has always intrigued us. It's a notion that transcends cultures and epochs, finding a place in the stories we tell and the dreams we dream. It is a concept that sparks wonder, curiosity, and a sense of awe. The idea that there could be other versions of ourselves, living different lives in parallel worlds, is both thrilling and humbling. It makes us ponder the infinite possibilities that lie beyond our current understanding. The possibility of other worlds existing alongside our own raises profound questions about the nature of reality, our place in the cosmos, and the very essence of existence. Are we just one of many versions of ourselves, each living out different scenarios in an endless array of universes? What if there are countless versions of ourselves, living out different lives in alternate realities? Each choice we make, each path we take, could potentially create a new universe, a new reality where different outcomes unfold. This idea challenges our understanding of free will and destiny. What if every decision we make creates a new branch in the fabric of the multiverse? Imagine a reality where every possible outcome of every choice exists simultaneously. This branching of realities could mean that there are infinite versions of our world, each slightly different from the other. These are just a few of the tantalizing questions that arise when we contemplate the existence of parallel universes. The more we think about it, the more we realize how little we know about the true nature of reality. It's a humbling and exhilarating thought. The allure of parallel universes stems from our innate desire to explore the unknown and to push the boundaries of human understanding. We are driven by a need to discover what lies beyond the horizon, to uncover the secrets of the cosmos, and to understand our place within it. We are a species driven by curiosity, constantly seeking answers to the biggest questions about ourselves and the universe we inhabit. This quest for knowledge has led us to explore the farthest reaches of space and to delve into the deepest mysteries of quantum mechanics. The concept of parallel universes offers a glimpse into a realm beyond our immediate perception, a realm where the impossible becomes possible and the limits of reality are stretched beyond our wildest imaginations. It's a tantalizing prospect that invites us to dream bigger and to question everything we think we know. Throughout history, philosophers, scientists, and science fiction writers have grappled with the idea of parallel universes. From the ancient Greeks to modern-day physicists, the notion of multiple realities has been a source of endless fascination and debate. Ancient Greek philosophers such as Democritus and Epicurus speculated about the existence of infinite worlds. They pondered whether our universe was just one of many, each governed by its own set of laws and principles. In modern times, the development of quantum mechanics and cosmology has provided a scientific framework within which the concept of parallel universes can be seriously considered. Theories such as the multiverse hypothesis and string theory suggest that our universe may be just one of many, each with its own unique properties and dimensions. While the existence of parallel universes remains a topic of intense debate and speculation, the very idea continues to fascinate and inspire us. It pushes the boundaries of our imagination and challenges us to think beyond the confines of our everyday reality. It challenges our preconceived notions of reality and invites us to consider the possibility of a much grander and more mysterious cosmos than we ever imagined. The idea of parallel universes opens up a world of infinite possibilities, where anything and everything is possible. The journey through the multiverse is a journey into the unknown, a journey that promises to expand our horizons and transform our understanding of the universe and our place within it. It's an adventure that beckons us to explore, to dream, and to imagine the unimaginable. Quantum mechanics, the branch of physics that governs the behavior of matter at the atomic and subatomic levels, has revolutionized our understanding of the universe. It delves into the very fabric of reality, exploring phenomena that defy our everyday experiences and challenge our classical intuitions. This field has played a pivotal role in shaping our understanding of the multiverse, a concept that suggests the existence of multiple, perhaps infinite universes beyond our own. One of the most bizarre and counterintuitive aspects of quantum mechanics is the idea that particles do not exist in a definite state until they are observed. This phenomenon is at the heart of many quantum experiments and has profound implications for our understanding of reality. This is known as quantum superposition, where particles can exist in multiple states at once, only collapsing into a single state upon measurement. Imagine a single particle, such as an electron. In the quantum realm, this electron can be in a state of superposition, existing in multiple states simultaneously. According to quantum mechanics, this electron can exist in multiple states simultaneously, such as spinning both clockwise and counterclockwise at the same time. This duality is not just a theoretical concept, but has been demonstrated in numerous experiments. It is only when we attempt to measure the spin of the electron that it collapses into a definite state, either spinning clockwise or counterclockwise. This act of measurement forces the electron to choose a state, a process that remains one of the great mysteries of quantum mechanics. This strange behavior of quantum particles has led some physicists to propose that each time a measurement is made, the universe splits into multiple copies of itself, with each copy representing a different outcome of the measurement. This idea is not just a flight of fancy, but a serious scientific hypothesis. This is the essence of the many worlds interpretation of quantum mechanics, first proposed by Hugh Everett III in 1957. Everett's radical idea was initially met with skepticism but has since gained a following among some physicists. According to the many worlds interpretation, every quantum measurement or interaction causes the universe to branch into a multitude of parallel universes, each representing a different possible outcome. This means that every decision, every random event, creates a new universe. These parallel universes exist alongside our own, but we are unable to interact with them because they are separated from us by an unbridgeable gulf in the fabric of reality. This separation is not just physical but also conceptual, as each universe follows its own unique path. While the many worlds interpretation is a highly controversial and speculative idea, it has gained traction among some physicists as a way to make sense of the strange and counterintuitive nature of quantum mechanics. It offers a framework that could potentially unify various quantum phenomena under a single theory. If true, it would mean that our universe is just one of an infinite number of parallel universes, each with its own unique history and set of physical laws. This mind-boggling idea challenges our very notion of reality and opens up endless possibilities for what might exist beyond our observable universe. Hugh Everett III, a brilliant but unconventional physicist, dared to challenge the prevailing interpretation of quantum mechanics with his many worlds interpretation. This groundbreaking theory was proposed in the late 1950s, a time when the scientific community was deeply entrenched in the Copenhagen interpretation, which posited that quantum particles exist in a state of superposition until observed. This audacious idea, initially met with skepticism and even ridicule, has since become a cornerstone of multiverse theories. Despite the initial resistance, Everett's theory gradually gained traction, especially as more physicists began to explore the implications of quantum mechanics beyond the traditional frameworks. Everett's proposal emerged from his quest to reconcile the deterministic nature of quantum mechanics with the seemingly random outcomes observed in experiments. He was driven by a desire to find a more comprehensive explanation that didn't rely on the observer's role in determining reality. In essence, the many worlds interpretation suggests that every quantum measurement or interaction doesn't force the universe to choose one outcome over others. Instead, it posits that all possible outcomes are realized, each in a separate, branching universe. This means that every decision, every random event, and every quantum interaction creates a new, parallel universe where a different outcome occurs. Instead, all possible outcomes are realized, each in a separate, branching universe. This idea fundamentally changes our understanding of reality, suggesting that the universe is constantly splitting into countless versions of itself, each representing different possibilities. Imagine flipping a coin. Instead of landing on either heads or tails, the many worlds interpretation posits that both outcomes occur, but each in a different parallel universe. This means that for every possible outcome of any event, there is a universe where that outcome is realized. This branching process, happening continuously at every instance of quantum interaction, leads to an unimaginably vast and ever-growing multiverse. The sheer number of universes created by this process is beyond human comprehension, making the multiverse an incredibly complex and fascinating concept. Each universe within this grand tapestry of realities represents a different path taken, a different outcome realized. These parallel universes coexist, each with its own version of events, histories, and futures, creating a rich and diverse multiverse. It's a mind-boggling concept, challenging our intuitive grasp of reality and suggesting a universe far stranger and more complex than we could have imagined. The many worlds interpretation forces us to rethink our place in the cosmos and consider the possibility that our reality is just one of countless others. Despite its outlandish implications, the many worlds interpretation offers an elegant solution to some of the most perplexing questions in quantum mechanics. It provides a framework that eliminates the paradoxes and inconsistencies of other interpretations, making it a compelling theory for many physicists. It eliminates the need for wave function collapse, a seemingly arbitrary process where the universe chooses one outcome over others. By suggesting that all outcomes occur, the many worlds interpretation removes the need for this controversial concept. Instead, it embraces the full scope of quantum possibilities, suggesting that all possible realities exist simultaneously within the vast expanse of the multiverse. This idea not only expands our understanding of quantum mechanics but also opens up new avenues for exploring the nature of reality itself. Moving beyond the realm of quantum mechanics, cosmology, the study of the origin and evolution of the universe, provides another compelling framework for understanding parallel universes. One intriguing concept within cosmology is the idea of bubble universes, a consequence of a theoretical process known as eternal inflation. Eternal inflation, an extension of the Big Bang theory, suggests that our universe, born out of a rapidly expanding bubble of space-time, is just one of many. In this scenario, the inflationary process, responsible for the initial exponential expansion of the universe, doesn't end everywhere at the same time. Instead, it continues indefinitely in some regions of space-time, creating a constantly expanding sea of potential. Within this sea, pockets of space-time can transition from a state of rapid inflation to a slower, more stable expansion, similar to what our universe experienced after the Big Bang. These pockets, each representing a distinct bubble universe, can have different physical laws, constants, and even dimensionality. Imagine a pot of boiling water. Just as bubbles form and expand independently within the pot, bubble universes emerge and evolve separately within the vast expanse of inflating space-time. Our universe, in this context, is just one bubble among countless others, each with its unique set of properties and potentially harboring its own forms of life and civilizations.